All right.
Well done, Doug. All right,
Okay.
Doug, thanks very much.
Recording.
And thanks everybody for joining me tonight. I'm going to talk about how AI is and will be impacting our lives. So AI is powering advances in medicine, weather prediction, factory automation, self-driving cars, many other areas. We use personal assistants like Siri and Alexa every day to help us complete simple tasks. We use face recognition apps to automatically label our photos. And Google Translate helps us understand foreign language web pages and talk to Uber drivers in different countries. A lot of beneficial applications. You can see them on the left, a lot of application areas. The most striking thing about AI that people notice is that most of these AI systems perform tasks that seem to require intelligence. And many of us wonder where it will all lead. Science fiction writers have pondered this question for decades. Some have invented a future in which we have our benevolent and beneficial robots like, can you see my pointer here, like C-3PO from Star Wars? And for those of you old enough to remember, Rosie the robot from the Jetsons. This is an android from the recent HBO Westworld TV series. And of course, this is our favorite android of all time, Arnold Schwarzenegger as the Terminator. So some science fiction writers pretend beneficial robots like C-3PO and Rosie, some evil robots whose only goal is to destroy humanity like the Terminator, and some who started off good but ended up evil like the Westworld androids. And in fact, there have been many technologists who've also predicted that AI will take over the world. Tesla founder Elon Musk says that AI is humanity's biggest existential threat and that it poses a quote-unquote fundamental risk to the existence of civilization. The late renowned physicist Stephen Hawking said it could spell the end of the human race. The good news is they're wrong. We don't have to worry about intelligent robots, good or evil. Okay, so I just got muted and unmuted. Can everybody hear me?
We can hear you.
If you can't hear me, let me know.
Yes, can hear.
Okay, thanks.
No problem.
Good. So we don't have to worry about intelligent robots, whether good or evil. None of you will ever meet an intelligent robot. Your children won't meet an intelligent robot, and their children won't meet an intelligent robot. And I'm going to try to explain why in just 5 or 10 minutes before I move on to the rest of the presentation. And then I'm going to talk about social issues that are caused by AI that you really should be worried about and what we can do about them. So there are two main types of AI systems: machine learning systems and natural language processing systems. If you drill down inside machine learning, supervised learning is the type of machine learning and actually the type of AI that is responsible for the vast majority of the AI systems that are out there today. There's also unsupervised learning and reinforcement learning, two other types of machine learning, far less impactful than supervised learning. All three types of machine learning, the most important types use neural networks, and the most important types of neural networks are deep learning neural networks. I'll talk about those in a little bit, but I'm not going to get into how they work. The first few systems in that first slide I showed you with the beneficial AI systems were mostly supervised learning systems. There were a few natural language processing systems. So I'm going to explain a little bit about how supervised learning systems work, and then a little bit about how natural language processing systems work. So let's start first with supervised learning systems. Every supervised learning system follows the pattern illustrated in this slide. You start with a set of input columns and an output column that you want to predict. So just as an example, is everybody familiar with Zillow.com? You can go on Zillow.com and look up almost anybody's house, and it will give you an estimate of what it would sell for if they put it on the market today. So how do they do that? They do that by starting with a big table of data. Each row in the table is one historical sale price. So they have historical sale prices from all over the country for a long time in the past. And in that table of data, the columns are things like the square footage, the number of bathrooms, the proximity to waterfront, and there are probably thousands of these columns. How good the school system is, and so forth. And the goal is to learn a function that will predict that historical sales price. So for all of these historical sales, what we want to do is learn a function that can predict the actual sale price. Okay, I'm having a little bit of problem here because everything I say is echoing in my ear. Does anybody else hear an echo?
Yes, we are.
Actually, you hear the echo also?
I do. Is there a Jody on the call? She's showing up as also talking, so maybe she's not on mute. And we're getting a bounce.
Yeah, just make sure everyone except the speaker on mute.
Yeah, everybody on mute again, and we should be okay.
Yeah. Okay, so this sounds better, I think.
Yeah.
Okay, so what Zillow does is they take this table of data, they run it through a supervised learning algorithm, and that supervised learning algorithm computes the best possible function for taking a set of input columns and predicting the output column. And then what they do, when you go on Zillow and you look up your own house to see what it's worth, they basically use that function to predict what your value would be in that output column. It won't be exact, but because it's such a large table of data, it'll probably be reasonably close. So every supervised learning system follows that pattern of learning a function. And that learned function is only good for one thing, which is to predict that sale price. And we'll come back to this later, but even if I take that function and I put it on a computer that's a billion times more powerful, say 30 years from now, all that computer will be able to do is predict house sale prices. It won't be able to think or reason. It'll just be able to execute that one function. So some of you might be saying that, well, that sounds a lot like statistics. It sounds a lot like linear regression that I learned in stats class years ago. And you'd be right. The big difference is that it used to be called boring statistics. Now it's called supervised learning, which is part of machine learning, which is part of AI, and therefore it's sexy. But there is another big difference. That boring old linear regression program, that boring old statistics program can be run on massive databases like Zillow's database due to the increase in computing power that we have today. And more importantly than that, computer scientists have developed programs that can compute much more complex functions than those linear regression functions. So I mentioned earlier, and you may have heard of neural networks and deep learning. What neural networks and deep learning neural networks do, they're just programs that can compute very complex functions. And then just like a function that predicts house sale prices, that's all that that function can do. It can do one thing. So, for example, if I wanted to develop a system that can recognize faces, I'd have a table of faces, and I'd have one face per row in my training data set, and the input columns would actually be the pixels in the image of the face. The pixels are the little dots that make up an image. The output column would be the name of the person. And then I may have a billion of these rows, and I would run a supervised learning system that would be a deep learning neural network, actually a specific type of deep learning neural network called a convolutional neural network. And it would learn a function that would be able to take as input a face and predict the name of that face. And what's amazing about it is when you run a function like that, say you use Google Photos or Apple's photo recognition software, you train it to learn the names of the people that you've taken pictures of, and then when you take a new picture, it recognizes the person or people in that picture by applying that complex function it learned. So researchers have developed facial recognition as one type of computer vision function. They started developing these computer vision functions around 2013. Actually, I know Doug's going to correct me and tell me that people have been working on it for 30, 40, 50 years. But they really started to get good around 2013. Over the last few years, the capabilities have been packaged up and they're widely available through vendors like Amazon, Google, Microsoft, many other vendors. And people are now putting them to work in applications. For example, in self-driving cars or in manufacturers who are attempting to build self-driving cars. We'll talk a little bit more about that in a couple of minutes. They're used to identify pedestrians, stop signs, lane markers. A Tesla will have about 50 different individual supervised learning systems. One supervised learning system that has a function for recognizing pedestrians, one for stop signs, one for lane markers, and so on. Researchers have also created other supervised learning functions that can translate language, and that's what Google Translate is. Detect spam, detect credit card fraud, predict which customers will buy a new product. Doctors can use supervised learning to develop functions to detect various types of cancer and eye diseases, pathology, imaging, genetics. Applications of this computer vision technology are far and wide. Supervised learning is also being used to fight world hunger by creating these training tables to predict perfect crops, seeds, herbicide applications. But every single supervised learning system in use today has learned a function that can only perform one specific task. It can only make that prediction that's embodied in that one function. So a system that learns to name the people in photographs can't do anything else. It can't distinguish between a dog and a cat. It can't answer questions, retrieve information, have conversations. In contrast, the AI systems of science fiction and human beings can do many, many different tasks. We can purchase goods at a store. We can carry on a conversation, drive a car, on and on and on and on. We not only identify people's names, but we know that people use eyes to see, and ears to hear. We know that people eat food, sleep at night, work at jobs. A system that can only perform a single function can't do any of these things. Most important, humans and science fiction systems have common sense knowledge of the world and apply that common sense knowledge to a variety of tasks. For example, we use our knowledge of gravity when we take a glass out of the cupboard. We know that if we don't grasp it tightly, it'll fall. We also use our knowledge of gravity when we drop our keys on the table at night. And we use that same knowledge to perform dozens of other tasks every day. A supervised learning system that uses linear regression or a neural network to estimate house prices or to recognize faces can't do any of these things. And there's, even more importantly, there's no way for it to evolve to do those things. Okay, so that's supervised learning, and that's why supervised learning, which is the most important type, will never evolve into an intelligent robot. So let's switch gears and talk for a minute about natural language processing, which is the other big area of AI technology that's impacting us. Most of us have used Siri or Google Assistant or Alexa on their smartphones. 50 years ago, we had ELIZA. Joseph Weizenbaum of MIT, I think it was 1966, created a computer system that could have dialogues with people like this one. So someone would sit down with ELIZA and say, men are all alike, and ELIZA would say, in what way? Well, they were always bugging us about something or other. ELIZA would say, can you think of a specific example? And these dialogues would go on and on and on. And people were convinced that ELIZA really understood them, which was really very scary to the creator of the system, because the creator of the system knew that ELIZA was just a dumb pattern matching system. The program operated on keywords and phrases and patterns. So, for example, ELIZA just mapped keywords related to the family, like mummy, father, that should say father, not F-A-T-H-E-R, not F-A-R-T-H-E-R. For any sentence that had one of those words in it, ELIZA would just say, well, tell me more about your mommy, or tell me more about your father. Or somebody said, everybody laughed at me, ELIZA would say, who laughed at you recently? And, you know, by doing that, it would have a believable conversation. And, you know, some people said, well, that's how psychologists work. Well, that may or may not be true, but so ELIZA didn't know anything about families. It just knew how to map keyword patterns to responses. Interestingly, Siri, Alexa, and Google Assistant work the same way. They're slightly more sophisticated, but essentially they recognize patterns of input known as intents and produce canned output. They have no understanding or common sense knowledge. All three systems have massive teams of people that sit around trying to think about what people want to say and create new intents to execute their question or their command. I'll give you a link to my website, but there's a whole chapter on how these chatbots actually work. So natural language processing systems, like supervised learning systems, have no real intelligence. And the techniques, these keyword patterns that are used to create these systems, cannot be used to create intelligent systems like C-3PO or the Terminator. And though I don't have time to talk about it, the same is true for other machine learning technologies like reinforcement learning and unsupervised learning. And most important, today's AI researchers just have no concrete idea of how to build systems with real intelligence. So as a result, AI systems like C-3PO and the Terminator while possible, rely on incredible breakthroughs. Nobody has any idea how to do them. And that makes them about as likely as time travel, warp speed, putting people into hibernation, invisibility, teleportation, and reversing aging. So on the left, the thing we shouldn't worry about with AI is that it's going to take over the world or try to exterminate us. What should we worry about? Will it take our jobs? Will AI cause accidents? Will it reduce our privacy, increase discrimination, impact our elections? All these things are real issues. And I'd like to talk about each of these briefly. So let's start by talking about safety. And on the safety topic, let's start with self-driving cars. The popular press would have you believe that no one will be driving a truck, car, taxi, or bus by 2030. Everyone, all cars, trucks, and buses will drive themselves. Well, I'm telling you, there's absolutely no way. Self-driving cars have two main components illustrated over there. There's a machine learning component, which is mostly a set of individual supervised learning functions. For example, there's a function for pedestrian detection and one for stop sign detection. There are supervised learning functions that'll predict if a car is in the left-hand turning lane, that it's going to turn left. But most of the software in self-driving cars is conventional software, non-AI software. For any of you who have ever written software or used software, it's written with all the standard software engineering disciplines. So that's where all of the decision making takes place. That's where all of the action planning takes place. That's really the brains of the software, but there's no intelligence there. It's just conventional software where the computer is instructed to do exactly what the programmer tells it to under exactly the conditions it tells it to. To understand what we can't do with AI in the area of self-driving cars, let's talk for a minute about the miracle on the Hudson. In 2009, Captain Sully Sullenberger had just piloted his plane into the air when a flock of Canadian geese took out the engines. The plane was only 2,900 feet above the ground. The pilots only had a few minutes to maneuver, and then the plane was going to crash. The pilots had received no training on the scenario other than to apply a few basic rules and apply their common sense. To decide the best course of action, they eventually factored in likelihood of the passengers surviving under various crash alternatives, the likelihood of injuring people on the ground, where rescue vehicles would be available, many other factors. And then they heroically landed in the Hudson River, and all 155 passengers survived, and no one was hurt. Pilots receive extensive training, but it's impossible for them to train for every possible situation. This was an edge case, one that they couldn't have been trained for. They had to use their common sense knowledge and reasoning capabilities. The same is true for automobile drivers. It's impossible to train them for every possible situation. They have to use their common sense knowledge and reasoning capabilities for edge cases. And most of us have encountered unexpected phenomena while driving. A deer darts onto the highway. A flood makes the road impassable. A tree blocks the road. A car approaches a construction zone. Black ice. Drivers fishtailing. Drunk drivers. We use our common sense knowledge. If we hear an ice cream truck in a neighborhood, we know to look out for children running towards the truck, and so on and so on. How is a self-driving car going to get that common sense knowledge? If the control software is all conventionally programmed, that means every possible situation has to be conventionally programmed. Well, that's almost impossible. Almost everybody who's driven a car can give you some unique experiences that nobody else has ever had. So how will self-driving cars do this? They're not going to. They're going to have a lot of difficulty. What happens when a self-driving car responds to an unanticipated situation for which it doesn't have programming? I'm not sure this is going to work. This is a video of an overturned truck and a Tesla Model 3. And you'll see the Tesla approaching in the left lane, and the truck driver is trying to tell it to move over. But the Tesla doesn't expect the pedestrian there, doesn't see him. The pedestrian has to jump out of the way. And because the truck is white, it doesn't even recognize that the truck was in the road. And that's why I believe it'll be a very long time before we'll see consumer vehicles, especially with self-driving capabilities, full self-driving capabilities. Just on that note, I knew this was going to happen. Now I don't know how to get it back to the presentation. There we go. That said, there will be self-driving vehicles. You know, for example, if you look at corporate campus shuttles or shuttles in retirement villages, where you just need an autonomous vehicle that's going to shuttle people at 5 miles an hour from this stop to this stop, there are going to be very few edge cases they have to worry about. And the number of edge cases increases in severity depending on the type of autonomous vehicle. AV stands for autonomous vehicle. Shuttle buses that operate in cities, maybe a few more edge cases. A delivery service, maybe a few more. City-based taxis are going to have a lot, but not as many as consumer vehicles. And trucks are perhaps the most difficult edge case. So in any case, I want to move on, but so before we allow self-driving cars or trucks or buses on the roads, you would think our government and our regulators would require manufacturers to prove their cars are safe, even for edge cases. But that's not happening. The federal and state governments, both here and in other countries, are racing to gain the technological lead in self-driving. For example, in Florida, if a self-driving car company wants to put a car, a truck, or a bus on the road without a safety driver, without a driver, and just turn it on and let it go, they're allowed to do it. That terrifies me. I own a house in Florida, and I'm almost scared to drive there. And most states aren't far behind Florida. So what I would say is, if you have any pull with regulators and you agree with me, let them know what you think, because I think we're doing this all wrong as a country. Other safety issues that we need to worry about: autonomous weapons. AI-based weapons of war would be really scary if the Terminator scenario were a possibility, but that's not happening. So AI-based weapons of war, AI gives them a little bit more capability, and it's a serious issue. But we already have remote-controlled UAVs, unmanned aerial vehicles. I think that's what they stand for. So you can have an operator sitting at a game console, directing a missile, seeing through the missile's cameras and using a joystick to direct it. The thing that AI adds to that is the ability to just say, go find Osama bin Laden and dump the missile on him. So it does add a little bit of scary technology, but but the bombs are already here. Autonomous applications, again, bad software is going to cause problems, whether it's AI or not. So we've had bad software that's led to the 3 Mile Island nuclear disaster, Boeing crashes. The one thing about AI software is that machine learning software is hard to test. And I think the one thing that we should push for as a society is that we shouldn't be using untestable software where the public safety is at risk, like nuclear power plants. Cybersecurity, again, it would be a big issue if you could infuse a virus with the intelligence to navigate a network and on its own find the gold. But that's not going to happen. AI increases the attack surface in systems like autonomous vehicles, so there are more places for hackers to attack. But in the end, AI will probably help more than it will hurt. People are developing AI systems to fend off cyber attacks. So I think in the long run, AI will probably do more good than harm there. Privacy. This is an interesting one. How many of you remember George Orwell's dystopian novel, 1984? In that novel, citizens were monitored 24/7 by, quote unquote, Big Brother. Today's computer vision technology makes 1984 and Big Brother possible. And in fact, it's happening in China. The Chinese government's Sharp Eyes project is connecting security cameras across China in an effort to monitor 1.4 billion people and identify and monitor their dissidents and criminals. It's humorous to think about it, but it's actually been used to catch toilet paper thieves. In the US, by 2021, the 20 largest international airports will be screening everybody using facial recognition technology to detect terrorists. The FBI has an image database of 640 million adults. The biggest problem with facial recognition technology is it's inaccurate, and it's especially inaccurate for minorities. And in fact, recently, Amazon, Microsoft, and IBM have stopped selling their technology to the government. Just as an example of how bad it can be, Amazon's facial recognition technology was applied to all the members of Congress to see if it identified any of them as terrorists. It identified 28 members of Congress as terrorists. The worst part about that was that half of those members that it identified were African Americans. And that's an especially big problem because 80% of congressmen are Caucasian. So it's discriminating against African Americans. And it's not intentional discrimination. It has to do with the fact that the data sets used to train the computer's vision systems are mostly images of white males. Employment is also something everybody's concerned about. Is AI going to take all our jobs? Here again, the biggest impact on employment would be if we were going to be able to develop intelligent robots, so-called AG, artificial general intelligence systems. If we could, then computers could read every book, take every course, do every job. But as we've talked about, that's not going to happen. So how many jobs will AI take, given that we're not going to get these intelligent robots that are going to take everybody's job? If you look at the history of technology, in the last 250 years, there's been no technology that's created mass unemployment. In 1776, 80% of all workers were employed on farms. So almost all of those jobs have been lost to technology because we produce a lot more food than we used to produce. So technology has enabled us to do that, and the jobs have gone elsewhere. My own belief is that there are many, many technologies today that are going to destroy more jobs than AI. E-commerce is destroying tons of retail jobs. Rideshare software is impacting taxi drivers. Robotics, which mostly non-AI robotics, are performing automation on the factory floor. Customer service agents are taking over from human customer service agents. And there's a technology called robotic process automation, which is automating sequences of computer tasks. It's called robotic, but it's really just conventional software mostly. These technologies are all going to take a lot of jobs, but like all the technology before them, they probably won't cause mass unemployment. And if they do, they're not AI. So AI isn't taking jobs. It isn't going to be taking a lot of jobs. That said, AI will take some jobs. These other technologies will take some jobs. And job loss is a very serious societal issue. We don't do a very good job retraining people who lose their jobs. And you know, I believe we should do a better job as a country and as a society in general. Okay, two more. Discrimination. Does anybody remember Billy Ball? In the 1990s, the Oakland A's Major League Baseball team produced the longest winning streak in baseball history using low-paid players. How did they do it? The secret was a supervised learning function for predicting player productivity. And that became the subject of a well-known book and movie named Moneyball. Many of you probably read the book or saw the movie. When Ann Milgram became the New Jersey Attorney General in 2007, she observed that the criminal justice system is using very little data. She decided to, quote unquote, moneyball criminal justice. So she created a supervised learning function to predict whether criminals would repeat their crimes. And she used it to influencing sentencing, release decisions, drug treatment decisions. Over that period, murder rates in Camden, New Jersey actually decreased by 41% and overall crime by 26%. The problem with these systems are termed automated decision systems. The problem with automated decision systems is that they're discriminatory. They're not overtly discriminatory. They're not intended to be discriminatory. They don't use input columns in the training data set like race, but unfortunately they use correlated variables like employment status, income, and neighborhood. And this leads to discrimination. And the same thing happens in machine learning systems. So if you build a face recognition system, and most of your training data set is white males, then the system's not going to do very well on recognizing women or in recognizing African Americans, and you get issues like you did with the computer vision system that identified a large percentage of African American congressmen as terrorists. Okay, and just one last thing to worry about, fake news. Fake news has been around since H.G. Wells broadcast a fake Mars attack in 1938. In our 2016 elections, a Russian troll farm sent out 1.4 million tweets of fake news designed to disrupt our elections. None of this was AI, but AI can make the situation worse. AI technology, actually unsupervised learning technology that we didn't talk about, can be used to generate fake images and fake videos. Imagine a scenario where someone makes a fake video of a presidential candidate's spouting racial epithets, a fake video. That would be very damaging. So this is a very serious issue. To me, I think part of the answer is serious penalties for fake news. And probably a lot of people agree that the problem is how you define fake news. The definition can't just be any news put out by anyone other than Fox News, as some politicians would have us believe. And additionally, you have to allow for legitimate satire. So it's a very difficult issue. So AI is exacerbating this issue, but it's also helping because there are now AI programs that can be used to detect fake news and fake videos. Okay, so I'm going to stop there and just summarize. So all AI systems are either dumb functions or just simple pattern recognizers. They cannot and will not progress to intelligent robots without a completely new paradigm, and no researchers really have a clue what that new paradigm might be. When I was doing AI in the late 70s and early 80s, we had a lot of ideas what the paradigm should be. None of them worked out. There's no reason to think that today's ideas are going to work out any better. But there are critical issues that require careful thought. We talked about safety, deception, discrimination, privacy, and one other, sorry. These are all real issues. They can have real solutions, but we need to focus on those solutions and separate out our fear of the Terminator. We're never going to see the Terminator, so, as a society, let's just focus on the real issues. So I'll stop there and take questions. If you want more information on how AI systems work, including unsupervised learning and reinforcement learning systems, I've given you a link to my website. It's a free online handbook. There are 15 chapters and 400 pages of information. And I also have a book coming out that discusses these social issues towards the end of the year. Okay, so if anybody's still awake,
yeah, Steve, I got a suggestion.
Hey,
there are questions coming in on the chat. If we could type the questions in, that might be easier and make it a more orderly sort of thing.
Sure.
Can you see the chat system? I see Brian Matamore from Growth Engine asks, can AI be used to generate original ideas?
Yeah, that's an interesting question. Yeah, I'm still looking for the chat. So AI can be used to generate fake news. So most of these generation systems are unsupervised learning systems. So there are systems that'll generate tweets. There are systems that'll generate, blog posts. And if you read them, they sound pretty good unless you really dig in and check the facts. And they usually have all their facts wrong because they don't know anything about the world. When it comes to generating creative systems like music and art, they do a lot better because there are no facts. I always go back to there was a Saturday evening review comic strip that had a bunch of people standing in front of at an art gallery, standing in front of this square box, having a highbrow discussion, and the janitor walks over and says, that's the air vent. So there's no right or wrong when it comes to creative works like music and art. So there's a lot of unsupervised learning systems that people are using to generate music and art. But original ideas, real original ideas like in a blog post, no. If you read a blog post or Twitter posts and dig down, they don't make any sense. The facts are all wrong. They're not capable, and they won't be capable of generating that type of original idea.
The next question is from Mike Svensson. Does quantum processing to AI change the impact profile? That is, do quantum machine learnings impact any of your conclusions about what AI can do?
Sorry, what was the word? Does cause? C-A-U-S-E?
Yeah, we're trying to figure out if quantum computing alters your conclusions.
Oh, quantum computing. Okay, so really fast computers, basically. Yeah, so that was kind of why I made the point earlier. If you take that supervised learning function that predicts house prices, and you put it on a computer 20 years from now that's 1 billion times faster, maybe that's a quantum computer. The only thing that computer will be able to do is predict house prices. So no, I don't think it impacts my conclusion.
I got another question here from Jason Liu. Does AI imply using large amounts of data?
So supervised learning generally implies huge amounts of data, huge training data sets of millions and billions of observations. Unsupervised learning, yeah, pretty much the same thing. And reinforcement learning, pretty much the same thing. Natural language system is kind of handcrafted patterns. And there are some parts of natural language processing that will use supervised learning, and those parts require lots and lots of data.
I got another question here. How about creating new inventions? Maybe use the US patent database as the inputs and a mashup function to create something new. And that's from Brian Matamore.
Yeah, it's an interesting question. It can certainly be done. The question is, will these things make any sense? How many inventions will you have to sort through before you get something that looks really good? It's kind of like the question of, if you put a cat on a piano, will it ever produce great classical music? Well, probably if you wait long enough and you put enough cats on enough pianos, one of them probably will.
So I recall John Koza had a genetic algorithm that produced electronic circuits, some of which have actually received patents. So he's essentially permuting through all the different combinations and using a criterion which essentially gives him a function of how a filter should work. So he's creating new filters as original designs, and they receive patents. It's not the process that humans use, but it is a process that results in something that perhaps has a germ of an invention. So
yeah,
maybe
absolutely.
There is a way to create
Absolutely.
patents, automate the inventors out of a job, I guess.
Yeah. No, absolutely.
Are there any other questions? I don't see anything from the chat. Let me see. If you raise your hand, we can unmute you. Let's see. I don't think we have any other questions. So I think that concludes our presentation for today. I want to thank you, and I hope the rest of the group will join me in thanking you. There is a way to issue applause. But frankly, I think it's under the more. You can put a thumbs up, and I'm going to put my thumb up there. And I want to thank you very much, Steve, for a great presentation. We'll have another presentation tomorrow at noon. And I remind everybody that if you want to join, you have to register in advance. And I thank you all for your attentions. Thanks, Steve.
Thank you, Doug.
Thank
Thanks,
you,
everybody.
Steve.
Thank you, Steve.
That was really good. Thank you.
Yeah, thank you.
Yeah. Thanks, Steve.
What's the presentation tomorrow on?
Okay, so tomorrow we're going to do a presentation by